Here's a few sample Beer's Law problems. So number one says, what is the absorption when a colorimeter with an extinction coefficient of 1.8 inverse molarity centimeters, so that is your little a there, and a path length of 3 centimeters, that's your B, is sent through a solution with a concentration of that's your C. So this is just A is equal to ABC, like so. And they gave you everything that you need. All you have to do is plug them in. So that's 1.8 inverse molarity centimeters times 3 centimeters times 0.025 molarities. And you get out your calculator and you go to town. So 1.8 times 3 at 0.025. Your absorbance should be, if I've done my math right, 0.135. Number 2 asks, what's the concentration if the absorbance is 0.8? They don't give you an equation or anything, and that line looks pretty good, so they're pretty much just asking you to guesstimate at this point. So 0.8 is there. We're going to go over until we hit the line, like so. Maybe a smidge down, somewhere right around there or so. Then we take that and we go down until we hit the line or so there. So it looks to be, to me, that it is right at about 0.5 molarity, maybe just a little bit below the 0.5 molarity, because again, that's 0.5. So it looks like we're hitting, I don't know, maybe 0.49 or so. So when you are guesstimating, just do your best guess. This one here is the same thing, except they actually gave you an equation for this guy. Now, we don't need the R squared equation. That's extra material. But remember, if you have a y equals mx plus b, it's really A is equal to 54.276 times the concentration minus your 2.7817 that's there. So, if they've given you 4 variables, they have to give you 3 of them, which means then that they're either going to have to give you the absorption and ask you for the concentration, or they're going to give you the concentration and ask you for the absorption. So which one is it? It says, what is the concentration? So they want to know what the concentration is, and if they tell you that the absorbance is the 43 units that's there. So all you have to do is take that 43 and plug it into this equation right here, and then solve. So I'm going to come down here, and this guy there is my X. So I'm going to leave him alone, and they said that my absorbance was 43. No worries. Plug them in and go to town. So that's 43. So that's going to end up being 45.7817 is equal to 54.276 times your concentration. Now you divide by your this 54.276, and you end up with, if I have done my math right, a concentration of 0.843 molarity. For our last one here, it's going to ask you which of these 3 settings should you use. Should you be using the green, should you be using the red, or should you be using the blue? Basically, should you be using 565, 635, or 470 if you want to examine the silver ions. So you come down here to your graph and you check out your silver ions. So your blue is at 470, so that is going to be right about, oh, I don't know, there or so. That's going to be tough to beat right off the bat. That's your blue. Your green is going to be at 565, so that's going to be, oh, I don't know, there or so. Whoopsie. Went too far. Your green is going to be about there or so. That's not very good. You could probably get some results there. And your red is going to be at 635. So that's going to be around there or so. So it looks to be that the blue is obviously your best choice to get the best response, assuming all of this information is correct.